Assalamualaikum and hello everyone. My name is Ahmad Amsyar bin Mohd Fauzi and I'm truly excited to present my research. So today we will explore how consuming dark chocolate impact perceived exertion and sprint performance in young active adults. I hope you find it as fascinating as I did while conducting it. Here's a brief roadmap of what we will cover. We will start with the background and the problem statement that sparked this research. Then we will move through the objective, hypothesis, literature, methodology, result, and wrap up with what it all means. Finally, I will show my timeline and references. So first, why dark chocolate? Because it makes from cocoa solids, cocoa butter and sugar, usually with 70 to 90% of cocoa. It's rich in flavonoids and antioxidants that can boost blood flow and reduce inflammation. Now, perceived exertion, or how hard an exercise feels, is measured by the RPE scale from very light to very high. For this study, we focus on short distance running, like 400 meters, which relies heavily on anaerobic system for quick bursts of energy. Despite growing interest in natural ergogenic aids like dark chocolate, most studies look at endurance sports or focus on women. There is still a big knowledge gap on how dark chocolate affects sprint performance and perceived effort in healthy young men. Since sport like track and field rely on explosive anaerobic power, it's crucial to know if dark chocolate helps or not. The purpose of this study that brings us to why this study was done. First, to see if dark chocolate can impact actual physical performance, specifically an 400-meter run. Second, to find out if it makes the run feel easier by lowering perceived exertion. So, the research objectives were clear. The first one is to assess the immediate effect of dark chocolate on perceived exertion, and the second one is to compare running times between dark chocolate and control trials. To test this, I set two null hypotheses. The first one, there is no significant difference in how hard the run feels between dark chocolate and control conditions. The second one, there is no significant difference in 400-meter running performance times between dark chocolate and control. Essentially, I wanted to see if dark chocolate could reject these nulls. Yearly research by Patek et al. Found that chocolate reduced oxygen costs in cycling, meaning athletes needed less oxygen for the same effort. From Davison et al. Show it improved plasma antioxidant status after prolonged exercise. However, very few have looked at short distance sprinting or perceived exertion immediately after consuming dark chocolate. This makes this study unique and fills an important research gap. Next is inclusion and exclusion criteria. For inclusion criteria, I chose male aged 18 to 25 years old with no cardiovascular, metabolic or neurological conditions, and also no cocoa or lactose allergies, and willing to comply and give consent. For the exclusion criteria, I won't choose participant that allergy or intolerance to cocoa, chocolate, and also lactose. Also, people who have cardiovascular disease, diabetes, asthma, metabolic, neurological, or respiratory disorders are not allowed to involve in this study. Also, people who have illness, injury, or musculoskeletal issue also can't involve in this study. And for people who can fast 10 hours, avoid caffeine, chocolate, or nitrate food for 24 hours, or attend both sessions are not allowed to involve in this study. And the next one is a females and others outside age range are not involved in this study. The study is designed as a crossover trial. I had 20 participants will split into two groups. 10 consume dark chocolate before the trial, and the next 10 act as the control group without supplementation. After a 1-week washout period, they will switch roles. Each participant ran a 400-meter sprint and then rate how it felt using the Mohd RPE scale. This flowchart visually breaks down the process. Before start the trial, both groups will do a 10 minutes warm-up. After that, they will do trial 1 under their assigned condition. 10 participants will consume dark chocolate, and the next 10 participants is under control trial, which is non-supplementation group. When they're starting to run in 400 meters, I will collect their time trial, and after they finish the run, I will collect their persistent accession using RPE box scale. Furthermore, to prevent injury, I ask them to do a 10 minutes cool down after the trial. After a 1 week of washout period, and then I will swap the group for the next trial too. This crossover method helps control for individual differences and strengthen the validity of our finding. I use several tools to ensure accurate data collection. The first one is a standardized 400-meter track for consistency. Next, a stopwatch to precisely time the sprints, and the next one, the Mohd RPE scale to measure passive accession immediately after each run. Also, finally, along with data sheets, consent forms, and screening questionnaires to manage ethical and logistical aspects. Our sample size was calculated using G-Power software for pair sample t-test with a cohen D of 0.97, alpha at 0.05, and power at 0.80. We needed at least 11 participants. To allow for possible dropouts, we increased it by 20% to a total of 13. This was modeled after Davison's similar studies on exercise and dark chocolate. But in this study, I chose 20 participants. The entire process was carefully planned. First, I will wait for the ethical approval. After that, participants will complete consent form and pre-screening. And then they were randomly assigned two groups to ensuring fairness. Each participant went through 2 trials, separated by a washout period to clear any residual effect of the dark chocolate. And then finally, I will do the data analysis. I analyze my data using Jamovi software. Check normality with Shapiro-Wilk test, and then perform pair sample t-test to compare running times and RPE score between dark chocolate and control trials. I set the significance at p less than 0.05 to determine meaningful differences. We move to the result and findings. For the passive assertion, the mean difference is negative 0.400. Participant rate assertion 0.4 points higher in the dark chocolate condition compared to the control group at t bracket 19 equal to negative 2.99. At p equal to 0.008, this result statistically significant at p less than 0.05. For the time trial performance, the mean difference is at negative 1.914, which is participant took 1.914 seconds longer under the dark chocolate condition compared to the control group at t bracket 19 equal to negative 12.04, at p less than 0.001. It shows that the result is highly significant. It's showing a very strong difference. What does this mean practically? dark chocolate reduce how hard the run felt. And then dark chocolate improve running speed even in a short distance class. Why? Because dark chocolate is rich in flavonols and theobromine, which may increase our blood flow and oxygen delivery via nitric oxide, and also decrease our perception of effort, which is possible central fatigue effect. I base my study on solid prior work. This is all my references. So this literature helped shape my hypothesis and study design. Here's a look at my timeline from proposal writing the last October to defending it, collecting and analyzing data, and finally submitting this July. It's been quite a journey, managing each phase carefully to stay on track. This is the end of my presentation. Thank you so much for your attention and interest.